Good morning, everyone.
Morning, Joe.
Can you hear me clearly?
Yeah, loud and clear.
Okay.
Dude, the physics book you gave us was hard, man.
Now I will discuss during
Gee, you got teach us all those formulas before. Actually. I had to Google the first answer, like the formula I need. I had to Google the formula for force.
most of it I assume you have learned this because this is based on last year's topic.
No, that
But it's okay, we will go through it lah. Don't worry.
in chapter 4 and all, we don't have that.
Okay. Okay, we'll just wait a couple more minutes before we start. Okay, can you all see my screen?
Yes, Joe.
Okay.
Yes, Joe.
Okay, I'm going to call out one by one. Please answer if you're here, yeah? Okay, Isaac? Okay, Isaac is here. Isabel? Isabel not here.
Not here, Joe.
Abigail? No, Abigail, no. Also not here. Carlos?
Carlos not here, so
Okay, Elijah? Elijah, are you here? Not here also. Okay, Kavishka?
Here, Joe.
Ricardo?
Here, Chair.
Okay, Pooja? Not here. Aaron? Not here. Zarib?
Yeah.
Michelle? Not here. Malcolm? Not here. Jared?
Here, Chair.
Judith? Judith not here, so what kind of number not here? Huh? Abigail here?
Yeah, yes, sure, yeah.
Okay. Carlos? Carlos still not here. Elijah?
Here.
Okay. Kavishka here. Aaron? Aaron's still not here. Okay, who is this 0108218091 on WhatsApp?
So repeat number again.
010-821-8091.
Me.
Oh, that's you. Okay. Okay, that's why I didn't call your name. Okay. Judith is Judith, are you here?
Yeah.
Okay. Malcolm? Malcolm's still not here. Okay, just give me a moment while I send in the group. Okay, Aaron, Michelle, Isabel, Malcolm. Any of your friends still not here besides the ones that I mentioned?
No, teacher.
Carlos, is
Teacher.
Carlos here?
Pooja?
Pooja is here, I think. Oh, not here. So, Carlos? Okay, Pooja is just joined. Carlos is also not here. Huh?
Carlos is not here.
Okay, never mind. Let's start then. Okay, good morning, everyone. So today we're going to continue on angles. We're going to look at angles in circles. But before that, let's just do a recap on what we have learned so far. Okay, so we have learned angles in straight line add up to 180. Angles in a triangle add up to 180 as well. Vertical opposite angles are equal, and angles around a point add up to 360. Okay, and then we also saw 3 facts. Okay, the first one, where alternate angles are equal, where they form a Z shape, so they are the same. And then we have number 2, which is corresponding angles are equal, so when they form an F shape, they are also the same. And number 3, interior angles add up to 180. They form a C shape, and then they add up to 180. So fact 1 and 2, they are the same. Fact 3 is they add up to 180. Okay? So today we are going to look at, we're going to look at angles in a circle. Okay? Okay, so please have your books ready. You'll have quite a lot of copying to do. And I would say please have a coin with you. Okay, you don't have to draw the circles with your geometric set because that will take a lot of time. But please have a coin with you or something round and not too big, something to fit in your book. It doesn't have to fit one whole page. One circle just as big as a coin is fine. So I'll give you all like 2 minutes. Just quickly go and get a coin or something round, and then we can start. Okay?
Yeah, this one okay.
How to see? Wait, let me see. Is your video on?
Yeah.
Okay, wait, let me see. Yeah.
Sure, I have a 20-cent coin. Is that okay?
Can. Yeah, can.
I have this plastic thing I just pick up on the table.
Can. Anything that is, as long as it's easy for you to draw a circle. Okay? Yeah, let's just give a minute or so for the rest of them.
Teacher, we're gonna copy a lot.
We've got quite a bit to do.
Okay.
A good
Are you
amount.
going to teach us circumference all today?
Circumference, no. This one is so in circles, right? There are angles as well. Just like how we looked at the exterior, interior angles and all. There are some like rules for angles in a circle.
Oh.
Yeah, so we're going to look at that. So like if let's say we have a circle with like shapes inside, how to find the angles. Okay, so you can start, for those who are here already, you can start by writing the topic for today, which is angles in circles. Okay, let me just quickly call upon everyone just to make sure everyone is here, everyone's back. Okay, Abigail here.
Yeah.
Elijah is here. Celeste, are you back? Okay, she's here. Isaac. Okay, Isaac is back. Jared.
Here, Teacher.
Judith.
Here, Teacher.
Avishka.
Here, Teacher.
Pooja. Ricardo.
Here, Teacher.
Sureka.
Here, Teacher.
Zarit.
Here, Miss Trina.
Okay, so everyone is back. Okay, let's start. So the topic for today is angles in circles. Okay, let's start. Okay, so remember, as we do this this part of the topic, right? Please remember all the things that you have learned in the previous classes. So like a triangle adds up to 180 and all that kind of stuff, because you will also need those. Okay, so let's look at this. The circle to the right with center O has a diameter of 20 cm. No need to copy this, this is just a starter. It has a diameter of 20 cm. And the perimeter of the triangle OAB is 36 cm. Calculate the area of the triangle. So we know that the diameter, this is the center, because it says center O. We know that the diameter is 20. That means if I were to draw the diameter, it would be like this. This is the diameter of a circle. Okay? So if I were to, this is the diameter. So what is half of the diameter called?
Radius.
Radius. That means this is the radius. So if the diameter is 20, what is the radius?
10.
10, which means this is 10. If this is 10, this is also 10, because this is the radius, the line from the center. And then the perimeter is 36. That means perimeter means this plus this plus this is 36. So if this is 10 and this is 10, what must this be? What is line AB? 16. Everyone following so far? Anyone lost?
No, Teacher. All okay.
Okay. Okay, so if this whole thing is 36, that means this is 10, this is 10, this is 16, because they add up to 36. So calculate the area. So we know that area is half times base times height. Okay, so this is how we go through. And then to know what this height is where we use Pythagoras theorem. So we're going to learn these things throughout. Okay. Okay, so let's go. Have you all learned Pythagoras theorem before?
Long time ago, Teacher, but I sort of forgot a bit.
Okay, we will do that in the next class. Okay, so the first one. Okay, we're going to learn about angles in a semicircle. Okay, just a moment. I'm just trying to reply. to a chat. Okay. So the angle, this is the first theorem. The angle in a semicircle is always 90 degrees. So if I have a circle and I have the line touching the circumference of the circle, circumference is the whole outside of the circle, then it should be 90 degrees. Okay. So please copy this one down.
Okay, must we draw all 3 circles?
No, you can just choose to draw one. Okay, so this is the first theorem. The angle in a semicircle is always 90 degrees. Then just draw one of the circles. Okay, just remember, this is the circumference. Okay. The outer, the whole thing, the whole circle, is the circumference. Okay, now one thing to remember, one thing to always remember for this rule, if not you will get it wrong, like it will not be right, the rule will not apply is, see, it's stated here angle in a semicircle, which means this line here is passing the center, because this whole thing is a semicircle. So this rule only works, okay, if the line of the triangle, the hypotenuse part of the triangle is at the center of the circle. So if let's say the triangle looked like this, okay, then it's not 90 degrees already. The line must be at the center of the circle. Then only this rule works.
So the hypotenuse must be at the center.
Yes. Okay, so if not, this rule doesn't work.
So do we also write the angle in a semicircle is always 90 degrees?
Yes, you have to write that.
Okay.
Please use your rulers to draw the triangle and everything.
So how do we know if the hypotenuse is actually at the center?
Sorry?
How do we know if the hypotenuse is actually at the center?
They will, so usually in a question, they will say, okay, the center of the circle is marked as O. And then, yeah, then you will know, okay, the line is passing through the center. So usually like in a question, they always tell you what is the center of the circle. Okay, who is still copying? Please raise your hand. If not, I'll move on to the next one. Okay, still copying. I'll give you all another 30 seconds more. Then we will continue. Okay, guys, just give me a moment. Yeah, I just need to do something really quickly. Okay, so let's go on to the next one. Okay. Okay, the angle at the circumference is half the angle at the center. Okay, this is the second one actually. This is the second rule. The angle, wait first, don't copy. I explain to you all. You all need to understand this, very important. The angle at the circumference, okay, remember our circumference is the outer part, that whole circle. The angle at the circumference is half the angle at the center. So if let's say the angle at the center, again, this is the center. Okay, again, this rule only works if the angle is at the center. Okay, so if this, so in your drawings, right, make sure you denote that that is the center. Although it's not stated here, you put there maybe C for center lah. Okay, the angle at the circumference is half the angle at the center. So if let's say at the center is 100, that means the angle at the top of that is 50, is half of it. Now, one very important thing to note, they must share the same of this. This is called an arc. A, R, C. Okay, this triangle, this thing here, and this part here, if you see, they share the same arc. Okay, they are all intersecting at the same point and they're sharing the same arc. When they share the same arc, then only this rule works. So 100 and 50.
See, does it only work for this shape?
Sorry?
Does it only work for this shape?
Wait, I show you what are the other ones. Okay, 100, 50. See, let's say if it's at the side, also 50. Why? Because they are sharing the same arc. They're intersecting at the same point and they're sharing the same arc. So the rule is they must share the same arc. Same thing here, you see? See this picture also, This is 15 means, what is the angle at the center?
30.
30.
20.
30, half. So double. So you see, they share the same arc. So even if the triangle is at the side, but because they share the same arc, the rule applies.
So what do you mean by share the same arc?
This thing here. You see this triangle and this, they share the same part here. They're intersecting at the same point here. Both the big one and the small one. This is called an arc. So because they share the same arc, that's why this rule applies. You see here also same thing. They share the same arc. It intersect here, it intersect here with the 100-degree triangle, not triangle, the sector. So because they share the same arc, that's why the rule applies. Okay, if we look at the next one also, 130, 65. Why? They share the same arc. You see here? They share the same arc. So this sector is like this, and this sector also like this. They share the same arc. So that's why this rule works. So if let's say, right, I were to have, let's say we look at the second circle, I have suddenly a triangle. Now let me just clear all of this. Okay, let's say I have a triangle suddenly like this here. Okay, so let's say like this I have. Now, do they share the same arc? This one and this one? Is it the same? No, this is outside. So this cannot be 15. Okay? Or if let's say I have suddenly this triangle here, I draw, but then instead of ending here, it ends somewhere here. So they don't share the same arc. This is smaller than the actual one. So this cannot be 50. Okay? And then, okay, another one here. So if this is 230, then this will be 115. Why? Because they share the same arc. Okay, so you see here, this one is this big arc. Okay, so please take this down. This is the second one. This is the second rule. So in brackets here, I would say, please write down, they must share the same arc. And then in your drawing, you denote, you highlight this part, and then right here, arc. Just to label so that you know which is the arc. This one also same. So in brackets, you write here, they must share the same arc. Okay, those who are still copying, please raise your hand. Okay, continue. Okay, if you're still copying, please raise your hand. Okay, I'll give you another 30 seconds and then we'll continue.
So what did you ask us to write the bracket up there?
They must share the same arc. ARC. Okay, let's continue. Okay, let's look at an example. Okay, please take down this question, copy everything down. So write question 1, write the question, and draw the circle. You see, it says line AB is the diameter of a circle. So automatically you know, because diameter, that means it must pass through the center of the circle. Because diameter always pass through the center of the circle. So AB is a diameter. That means the center might be somewhere here lah. Maybe here. So you can denote a C there. Okay, and then write out this question first, draw, and then we will look at it. You can also try and figure out the answers as well, and then we will discuss. Okay. Who's still copying? Raise your hand. No, I will start discussing the question. You're still copying. Okay, keep going. Okay, come, let's look at this. So line AB is the diameter of a circle. Angle CAB is 50. Okay, angle CAB means 50. Is 50 means we want to know whether is it C, is it A, or is it B? Because it says CAB. So how to know is, the rule is the alphabet in the center. That is what it's referring to. So if it's angle CAB means you look at the alphabet in the center A, that is 50. If it's BCD means the middle is C. So you look at angle C, that will be whatever value. So when it says angle CAB, because there's C, there is A, there's B, all also got angle. So when it's CAB, the rule is the middle part is what it is referring to. So A is 50 degrees. Okay. Now calculate angles X and Y and give reasons for your answers. So what is X? Anyone want to try? Anyone? Remember the rule that we learned?
So is it 90 because it's in the center?
Correct. So X will be 90 because based on the first rule we saw just now, when I have a semicircle and then I have a triangle there, the top part here is 90 degrees.
Yeah.
It's 9, yes?
So how do you know where to put the 90 here? Whether it's X or Y?
Because it's always at the, this is the hypotenuse. Remember the hypotenuse is the is at the center of the circle, and then opposite it lah, where the one that touches the circumference opposite to the diameter.
So, but, oh, okay.
So this is 90, this is 50. So we know that from previous lesson that a triangle gives you 180. So if this is 90 and this is 50, what is Y?
90, 40.
Correct. So 90 plus 50 is 140. Then 180 minus 140, Y is equal to 40. Okay, so you write down lah. Angle X is 90 degrees. Why? Because the angle of a triangle in a semicircle, 90. And then for Y, it is 180 minus 90 minus 50. Okay, anyone confused or anyone needs me to explain again?
Me, Chair.
Okay, so let's look at it again. Line AB is the diameter of a circle. Let me just clear this off. Okay. So line AB is the diameter of a circle. So line AB. So remember, diameter means that means it is going through the circle. It's passing through the circle. Okay. So this is the diameter. And then if we look at the rule just now, if we look at the previous rule, this one. Okay. When I have a diameter like that at the center and I have a triangle, it has to be 90 degrees. Okay, remember this rule? 90 degrees, 90 degrees, 90 degrees. So that means this question, okay, C is, because this is the diameter of the circle, on top here is 90 degrees. Okay, and then it says CAB is 50. CAB. So there's C, there's A, there's B. Which one are they referring to? You always look for the center of the middle alphabet. A is 50. Okay, so A is 50. So you want to calculate angles X and Y. So we know that angle X is 90 degrees. Angle in a semicircle, we looked at the rule just now. Okay, and then angle Y is, angles in a triangle always add up to 180. So 180 minus 90 minus 50 is 40. Can understand?
Yeah, sure.
Pooja can? Okay. So this is the answer for it. So you take down this explanation so that you know what you're doing. Okay, I'll give you all about 30 seconds quickly. Okay, so that is that. Anyone still copying? Can I see a show of hands? Okay, all done. Let's go on to the next one. Okay, question number 2. Okay, line XY again, diameter of a circle. XY, diameter of a circle. What is the sum of angles A and B? Explain your answer. Okay, who wants to try?
You can try.
Okay,
So given that x and y is in the center, so that unknown angle there, which is not labeled A and B, will be 90 degrees.
correct. And then, so what will be the sum of A and B? So they're not asking you separately A and B. What will A and B equate to?
A and B equate to.
Hmm.
So first we find A. So since 90 degrees, 180 minus 90 degrees, you get 111. No, wait, 110. All right.
No, 180 minus 90?
Oh, yeah. Wait, you get 90 degrees.
Correct.
So then, since you have two angles ready, you minus it off with 180. But then that would be wrong because that would make it 0.
Correct. So basically you got
What?
it. You got it right. The sum.
0?
No. You got half of it right. So
Oh,
the sum is equal to 90. Why? Because the unmarked angle is 90 degrees, like Elijah said just now. Okay, because it's an angle in a semicircle. So angles in a triangle add up to 180. So if the unknown part here is 90, then A plus B together must equal to 180 minus 90, which is 90 lah.
so 45.
No. They're asking you A and B together. They didn't ask you A and B separately.
So it was A and B separately with 45 lah.
Well, no, not necessarily. It can be something else, but when you add them together, it will equal to 90.
Okay.
Because plus this 90 will give you 180. Okay, so please copy this down. Okay, see, there's not enough information here to work out A or B. That's why they ask you A and B together. So it's 180 minus 90. So A and B will be something that adds up to 90. Okay, so please copy this down. Okay, and anytime while I'm explaining your loss or anything, make sure you let me know, okay? If not, I would assume that you all are understanding what I'm saying. Okay? Okay, those who are still copying, please raise your hand. Okay, I'll give you all another 1 minute. Okay, let's move on to the next one. Okay, let's look at this. Calculate angles A and B and give reasons for your answer. Okay, who wants to try? This is based on the second theory, second rule that we looked at.
Yeah.
Yes.
I think the angle like on top of 120 is it? It's half of it.
Okay, so half of it would be?
Wait, let me calculate. 1, 2, 2, 61.
Correct. And what would B be? A is 61, B?
Oh, A is 61 actually. I thought it's the angle between A and B.
You mean here?
Yeah, and then it's vertically opposite, so both the sides will be 61.
Oh, no, you just use rule number 2. Okay, rule number 2, this one. See, 100 means the top is 50. This is the rule. 30 means 15.
Yeah, that means both sides are 61.
Correct, because they share the same arc. You see this one and this one, they share the same arc. They're all intersecting at the same place.
Okay.
So which means, this question, angle A is 61 because the angle at the edge is half the angle that's at the center. B is also 61. It's just that the angle has moved around a bit, but they're sharing the same arc. Okay, please copy this down. Okay, can I see your show of hands for those who are still doing? Okay, let's go on to the next one then. Okay, let's look at question 4. Work out the two labeled angles and state reasons for your answers. So we want to work out angle S and angle T. So let's look at angle S first. It's the simpler one. So what rule can we use?
The first one, sir.
Yeah.
If it's 90 degrees, then 90 minus 72.
No. What is the angle in a straight line?
180. Plus 180 minus 72.
180 minus 72. It is 108. Okay. Now, I have 108, and then what is angle T?
Don't use the same rule.
Which rule?
180 minus 108.
Why 180 minus 108?
Because angle O and T is in the straight line, right?
Oh, but if they are not touching each other, like 72 and 108, they are side by side.
Yeah.
Is it 36 angle T?
Why 36?
108 minus 72.
Why minus 72?
Because it's in a...
So can one of the vertically opposite, the alternate and corresponding angles be used here?
Can you find a Z or a F?
Not a straight one. No.
So straight one, yes, 180. Okay, let's see. Okay, so triangle ABO, this means triangle here, is isosceles, as two sides are the radius of a circle. Okay, so here, just note it. Okay, so here and here. Okay, so because they are a radius, they are isosceles, which means their angles are going to be the same. This one and this one. Okay, so I have the two angles at the base will be equal. So 180 minus 108 is 72. 72 divided 2 is 36. Okay, another rule that we can look at the rule that we learned today. If you see carefully, now this is what you need to do when you're dealing with questions like this. You have to really look at it, like really try and figure out all the rules that we can apply. You see here, there's actually a rule that we learned today that we can apply. Let me just look for my mouse. I lost my mouse. Wait. Okay, so you see here. Okay, today we learned this rule, right? If this is, you see, they share the same arc. This one and this one. They share the same arc. So if this is 72, what is this?
36.
Correct. Half of 72 is 36. So T is 36. See, they share the same arc. This one, here. This one, also here. So this is automatically 36. Okay? Okay. Okay, can you please copy down?
Mm.
Okay, once you have copied this, you can go and take a quick break. Come back at, now it's 10:08. Come back at 10:15. Okay? And then we'll continue. Let's continue. Okay, so this is, just give me a moment. Yeah. Continue. Okay, so again, I have this. Work out all the missing angles. Let's just quickly look at it. So I have angle A, okay, O being the center. Angle A will be 50 degrees. Okay, let's see. Angle B, 80 degrees. Okay, because here I've given you 50. See,
So why 50? Huh?
yeah, okay. So it's given here as 50, correct? Angle OBC is 50. And then this is the radius. This is radius.
Other please.
Yes. So this is the radius. So because it's the radius, both is same size, same length. Because same
So then which is the diameter?
There.
Oh, okay.
Diameter
Okay.
can be this line, can be this line, can be this line, as long as it passes through the center.
Okay.
Okay, so I have this and this being the radius. This is also the radius. Okay, so when this is radius, that means they are the same size. Same size means they're going to have the same angle. That's why if this is 50, A is also 50. Okay, A is 50 because isosceles triangle. Okay, it's the same. Okay, and then B is 80 degrees. B is here. Why? Because B, 50 and 50 will give me 180 because triangle. So 50 and 50 is already 100, and then 180 minus 100, B will be 80. Okay, and then C, because this is 80, this will be 100 because this whole straight line will give me 180. And then D is here. Okay, we know that angle in a semicircle, this is the diameter, it means this whole thing is 90 degrees. So D will be 90 minus 50, which is 40.
So can I explain D again?
Remember the first rule that we looked at when I have a semicircle and a triangle inside it, and then the hypotenuse is the diameter, and then opposite it will be 90 degrees.
Yeah.
So this whole thing is 90 degrees.
Yeah, but if it's the radius and it's 100, right, can't you just minus, like you just half 180 minus 100? So
Can
you
also?
get 2.
Can also.
Oh, okay.
So that's 40, and then E is also 40 because, yeah, isosceles triangle. So like you said just now, this plus this must give me 180. And then if I minus 100, I have 80, and this is the radius. So they will have the same size. So 80 divided 2 is 40 also. Same thing, lah. Same way, you can do it in a different way. Okay, anyone have any questions or confused?
No, sir.
No. Okay, you don't have to copy this down. Okay, so remember, angle in a semicircle is always 90 degrees. Okay? So this is just a proof, so just watch now, you don't need to copy. The circle has a triangle drawn inside it where the circle has been split into 2. Imagine we drew a line from the point of the triangle to the center. Okay, the smaller triangle created is isosceles because 2 sides are the radius, this one and this one. Okay, if we label the equal angles x, then the other angle is effectively, if this 2 is x, then that angle, the third angle is 180 minus 2x. Okay, which means the other side would be 180 minus 180 minus 2x, because it's a straight line. So I would get 2x. So that side is 2x. So apply the same logic to the other triangle using y, and then you will get the other central angle as 2y. Okay, this is just a proof lah. how they came up with that. Okay, nothing crazy. Okay, so from now we have learned two circle theorems where the angle in a semicircle is 90 degrees. The angle at the edge is half the angle at the center. Okay, the one where they share the same arc. Okay, any questions so far?
No.
No, Chef.
Yeah.
Let's look at the next part. Okay, yes, Pooja, you have a question? Okay. Okay. Let's continue then. Okay, Pooja, later you just watch the recording, lah. Okay.
Like the moment it starts to give, it goes back down. Yes,
Okay, let's look at the second part. Okay. Okay, let's look at this. Work out the missing angles and state your reasoning. O is the center of the circle. AD is the diameter. So A is 90 degrees because I have AD is 90 degrees. I mean AD is the diameter, so opposite is 90 degrees. So B becomes 58 because the triangle minus 90 minus 32, I get 58. And then these two is the radius. So 55, 55, because 180 minus 70, 110, then I divide 2 and get 55, 55. And then E, I have a straight line here, 180 minus 70, E should be 110. Okay, and then this and this is also the radius. So I take 180 minus 110 is 70, and then I divide by 2, I get F and G. Okay, 35, 35. Okay, anyone did not get that or don't understand what I did just now? Okay, all okay, yeah? Okay, so we have looked at angle in a semicircle, 90 degrees. We've looked at the angles on the circumference at the center. We have double, half of it. Okay, the angle at the circumference is half the angle at the center. Today we'll learn another rule that can be used. So now we're going to look at another rule. Okay, angles in the same segment are equal. Okay, this is the bow tie rule. So let's say I have a circle. They will have the same angle.
If we could have used this for the question just now, right?
Yeah, can? Okay, so the angles in the same segment are equal. See, see carefully what's happening. So I have the minor segment and the major segment. So in a circle, the small part, the small piece here is minor segment. The larger one is called the major segment. Okay, so you see the triangle and the triangle here. They are both 34. Okay, same thing here. They will share the same angle, 23, 51. See, again, this is very similar to the second rule we looked at. You see, you know how we talked about halving? You see here, so this one and this one. They both touch the circumference and they both intersect and they both share the same arc. So they both have the same angle. If you look at the other part, okay, see, the one that is the bottom angle, 51. Also, they share the same thing. You look at it upside down. This one and this one. See, they intersect at the same place. and they share the same arc. That's why they are both 51. Okay. Another one. Watch carefully. They're intersecting at the same place, so they will be the same. Okay. Please copy this down. This is the third rule. Okay, can I have a show of hands, those who are still copying? Okay, still copying. Okay. I'll give you all another 30 seconds. Okay, let's go on to the next one. Okay, let's look at this. Calculate angles P, Q, and R from the information given. So angle P will be, what will angle P be? Anyone?
$29, Aja. No, wait, 27.
27, because they're in the same segment. And then angle Q will be,
29.
29.
29.
and then what would R be?
180 minus the sum of both those angles.
124 degrees.
Because they form a triangle. Okay? Let's look at the next one. Angles WXYZ from the information given. AD is a diameter. So if AD is a diameter, what does it make this angle?
90.
90, correct, based on the first rule we looked at. So this will be 90. Okay?
Before, because the PSC,
Then what is angle W?
so it's considered ultimate.
15.
Yeah, but would take out the diameter, it will be 15.
The last.
Okay? And then what would angle X be? Remember the first rule we looked at?
Angle X.
What's the first rule we looked at today? I have a diameter in a semicircle and then I have an angle there.
90 degrees.
90.
Correct. See the triangle there? So 90 degrees. Similar to the one here. Okay, so that is 90 and that is 15. What does it make Y?
Actually, if you ask me,
It's a triangle there, small triangle there.
15.
75.
75, because this is also a small triangle here.
that is the issue actually.
Okay. And then what does that make Z? It's a straight line there. So I have 75 on this side. What's there on the other side?
105.
105. 180 minus 75. Okay, Ken?
Yes.
Okay. Okay, let's look at this. A is here, 101. Why? 180 minus 79. Okay, so that gives me 101. So which means what would B be?
19.
B. I have 101 here, I have 19 here. So what would this be? I have a triangle here.
Mm.
60 degrees, sir.
How do you get 60?
109 plus 19 equals to 120. So 180 minus 120 is 60 degrees.
Why 180 minus 120?
Because a triangle is 180 degrees.
Correct. So B will be 60 degrees. Okay. And then look at this. So this is why I say when you have these questions, you have to look at it in every single possible way, because there's actually like so many rules that can be applied. So what?
Teacher,
Yes.
we use vertically opposite angles for this because 101, then the other side will be 101 also.
Which side?
Do you know the angle?
Opposite.
Yeah.
Okay. Let's see. 60.
Is it vertically opposite?
Is it vertically opposite? Let's see. 19. No. But actually, yeah, it will be. It will be vertically opposite. Yes. It will be vertically opposite. Okay. Now let's look at this one. So C will be 60 degrees because they're in the same segment. What would D be?
19.
19. Okay, this is a rule we looked at today. And then we have a Z here. So what would E be?
Oh, okay. So this angle.
If this is 60,
41.
this would also be 60.
60.
41, Joe.
So 60 is 19 plus 41. So E is,
So it's not like a major takeover.
E is 41.
It's quite hard to spot the
Correct.
patterns.
That's why you have to really look at it and try to see where I can apply all the rules so that I can get all these little angles. Okay? Okay, anyone have any questions so far?
No.
No.
Okay. Okay, so that is that for this part. Okay. And then we look at this one, next one. Okay, I have a cyclic quadrilateral, which is a quadrilateral that can be drawn on the edge of a circle. Okay, this is what we call a cyclic quadrilateral, a quadrilateral that can be drawn on the edge of a circle. Okay, you see all the four sides are hitting the circumference. Remember, that's the key here. All the four sides of the quadrilateral is hitting the circumference of the circle. So there's no like one dangling in the middle. It's all hitting. Okay, so please copy this down and then you can just draw one. You don't have to draw all three, draw one. But please note that each side, each point is touching the circumference. Okay, quickly copy down, copy the definition and draw one example. Okay, let's continue. Okay, so this is the next rule. Opposite angles in a cyclic quadrilateral add up to 180, which means Again, our cyclic quadrilateral must touch all sides must touch the circumference, all points. So if this is 85, the opposite of it will be 95 because they must add up. The opposites must add up to 180. If this is 88, what would the opposite be?
180 minus 88.
Correct. So 92.
Yeah.
Same here. Yes.
Who came up with these rules?
Some mathematician lah. I don't know what's his name.
How do they come up with stuff like this?
So so if you see just now, right, there was one part that said proof. So they look at these circles, they look at the properties of it, they use their basic math ideas, and then they see, oh, this is equals to that, that is equals to this, and then they come up with a rule.
Oh, okay.
Yeah. So all these rules actually have proof to it. If you want, you can go online and you can check like what is the proof that this rule is correct, and then they will explain. Yeah. So there's all proofs to it. Like, it's not that they simply came up with the rule. Okay. So same thing here. You see, all the four sides are touching. They might not be. It might not take the whole circle, but all four sides are still touching the circumference. So if that's 30, the other side 150. This is 140. The other side is 40. Same thing here, 99, 81, 77, 103. Okay, so this is the next rule. Please copy down and then just copy one of it lah. One example. So this is the next rule. Okay, can I have a show of hands of those who are still copying? Okay, I'll give you another 30 seconds. Okay, let's continue. Okay, an exterior angle in a cyclic quadrilateral will always be the same as the opposite interior angle. Okay, what does that mean? So let's say I have, again, a cyclic quadrilateral. Okay, 73. So the outside will also be 73. Inside will be 180 minus 73. Outside will be the same. Why outside will be the same? The logic behind it is, if you look at this will be 180 minus 73, correct? Because opposite. So if this is 180 minus 73, it will be what is it? It will be 107. Okay, correct. And then this part here, because it's a straight line, this part here will be 180 minus 107, which is 73. So that's why they are the same. Okay, so that's why it is such. Okay, this is 88. The other side is also 88. Inside will be 180 minus 88. Outside will also be 180 minus this angle, which is 88 lah, because this is a straight line. Okay, same thing here. 104 means there's also 104 outside the exterior angle. 107, 107. Okay, so 45 here is 135 because opposite must sum up to 180. That means the outside here will be 45. Same thing with the other side also. Okay, okay, this is the next rule. Please copy and then just copy one example. Okay, can I see a show of hands of those who are not done?
So you need to copy one question, right?
Yes, one example. I'll give you all another 30 seconds. Okay. So if we look at this, okay, angle A is 68 because 180 minus 112 is 68. So if A is 68, B will be 112 because the exterior and the opposite of the interior. Okay. So C will be, what will C be? What will C be? If this is 93, what will this C equate to?
180 minus 93, Aja.
Correct. Which is 87. Okay. Okay, let's look at this. Angles P and Q, and explain how you got your answers. O is the center of the circle. ABCD is a cyclic quadrilateral. If this is 102, what is P? The second rule we looked at.
51 answer.
Yes. So angle P is 51, because half the angle at the center. If this is 51, P is 51, what is Q? It's a cyclic quadrilateral. So the opposites must equate to
129.
yes, correct, because the opposites add up to 180. Okay, so you see in one question, there are so many rules that you can apply. So you have to be aware of all the rules. So you have to remember all the rules. And the more, for this kind of questions, the more practice you do, the more you'll be able to see all the little rules that are incorporated into your question. Okay?
Mm.
Okay, let's look at a couple more before we end. Okay, ABCD is a cyclic quadrilateral again. O is the center of the circle. Line AC is the diameter. Work out the missing angles X and Y. Okay, very quickly. If AC is the diameter, what is the angle at B? Based on what we learned today, the first rule.
90 degrees.
90 degrees. Okay, see here, this produces a Z. So if this is 43, what is X? See the parallel lines here? Based on what we learned last week, if this is a Z, what is X?
43 also.
43 or so. Okay, alternate angles. Okay,
Yeah.
yes.
In the exam, will you give us questions like this that are like super hard to see?
I cannot remember. I prepared the questions long time ago. But I will have a look at it again, and then when we do revision, I will let you know. Okay, angle Y. So I
90 minus 43,
Y 90 minus 43?
because it's in the middle B.
In the middle. So this is 90, but Y is
Semicircle like that.
semicircle. That means this whole thing must be 90, but Y is only one part. What?
47.
47? Let's see. So look at the diagram. So I have a triangle. Both is the radius. So they are both the same, which means the other side is also 43. And then you take the 90 minus 43. So Sureka, you said just now, right? The the diameter and the circle there, the first rule. So now you take 90 minus 43. You will get 47.
47.
Okay? Ken?
Okay.
Yeah.
Okay.
Yes.
So 47. So opposite angles in a cyclic quadrilateral add up to 180. Okay? So again, all this has proof. Like you can go and check it out. Okay? So today we looked at two new rules as well. I mean, this section altogether we looked at 4. So for this section we looked at how the opposites. So the first two was semicircle 90 degrees, angle at the circumference is half at the center. That's the first two we looked at. And then we looked at angles in the segment are equal. Remember these ones? This was the third one. And then the fourth one was angles in a cyclic quadrilateral add up to 180, the opposite. So today we looked at 4 rules. Okay, There are a couple more rules which we will look at in the next lesson. Okay, anyone has any questions?
No, teacher.
No.
No? Okay, so I'll upload some questions on Edmodo, so you try it out there lah. Okay? Okay, that is all for today's class. I will see you all next week, Tuesday, for physics.
Okay.
Bye,
Bye.
teacher.
Right, teacher.
Alright, bye, sir.
Have a nice
Bye.
weekend.
You too, have a nice weekend. Bye.
Thank you.
Bye.